Okay, so we give an introduction of what is Circle Up, what is the project about. Actually, first, it's not in the agenda, but we were thinking to do a small introduction of who is actually here today. We know the partners of the consortium, but there are a lot of more people, nice young faces. It's good to have you here. So we'll start with an introduction of the partners of this project, and then maybe you guys can say your name and the school where you're from, so we all know each other. Yeah, I start. My name is Olga, and I am the coordinator of Circle Up, and I work for the University of Mälardalen in Sweden. So we take care of different projects and do the coordination and management of collaborative research projects. Nice to meet you.
I'm Paolo Manes, I come from Milan. I work for the chemical industries in Italy, so we try to support the chemical competitiveness of Italian industries, but is of course require all the manufacturing industry. But we will see it from.
Good afternoon, everybody. My name is Maria Chiara Pizzone. I'm here representing an Italian partner, CSCI, which is a consortium of schools, municipalities, and enterprises. Thank you.
My name is Claudia. I don't go to the same school. So I'm partners with a non-formal learning club called US.
Okay, my name is Vaida. Actually, I'm working at Thomas Jonas Labonskis Gymnasium, but I'm in collaboration with the Vytautas Magnus University Classical Education School, and I'm working in this project as well.
Hello, my name is Aida. I'm a colleague of Vaida. I'm from Jonas Labonskis Gymnasium.
My name is Rita. I am from College Jesuit High School.
Hello. My name is Agla. So I work in Vytautas Magnus University. Not university, but at school, yes. So today I'm here as a helper, so if someone is not okay,
I'm coming from the school, but I'm not a student. I'm a chemistry teacher. I'm a partner in the project Circle Lab, and I come from a secondary vocational school or the Chotala from Prilep, Macedonia.
I'm from me also.
My name is Elena Pereska. I come from the same school, the Chotala in Prilep, and it is a vocational high school. And I say hello to everyone from our school if they are watching and listening to us.
Hello, my name is Petar Stoczewski. I come also from Macedonia, but from the ecology department in this project. You will join me to play the game later on.
Hello, my name is Maria. I'm also part of this project now, and I'm doing my PhD in chemistry, and I'm from Spain.
Okay, my name is Ann-Sophie, and I'm a chemistry teacher from Sweden, and I'm in this project from the Ljubljanska Gymnasium.
Hello, my name is Emil Larsson. I am a chemistry teacher from Sweden, colleague with Ann-Sophie.
Hi, my name is Oscar. I'm from the Department of Communication at the University of A Coruña in Spain. From the center of Adventis, a scientific research center, it's a STICA, and we are part of the Central Lab project.
Hi, I'm Yolanda. I'm head of Vytautas Magnus University Classical School, and I am partner on this project.
Thank you all. So, from what I understood, we have two schools from which we have students. Yeah, good. So welcome everyone. Actually, we didn't present the two people at the back, but I can introduce them. Leo Atavani from MDU University is from the same place where I work, and also Caroline Roussault. And Leo takes care of the intellectual output 4, is going to give you a presentation, and Caroline is, for now, the communication officer. Okay, so first I wanted to explain a little bit what is Circle Lab. So Circle Lab is a project that has been funded by the Erasmus K Action 2 call, Zero Operation for Innovation and Exchange of Good Practice. And it's part of Circle Lab. We have 9 partners from 5 different countries. Everybody's here except for, yeah, we have some people that would be presenting today, but there is still representative for each partner. So yeah, they will present online actually. And yeah, so we already presented. We have Mälardalen University, which is the coordinator. Radbekianska. We have University of Coruña, Consorzio Scuola Comunità Impresa. I think you guys changed the name, so I'm sorry.
Classical school.
Classical school. Yeah, I will change this. Non-formal learning club, and so or the Copella Freeland, and then Ecologic. So what is the point of the project? So we know that circular economy is, we should transition to circular economy soon, because that will help a series of things. We have in particular a boost of about 1.8 trillion euro by 2030. We could have 1 million new jobs across Europe, and also cutting the greenhouse emissions of the chemical industry could be the leading motor for this transition. And of course, a circular economy will prevent waste and the emission of CO2. So we are trying all to move towards this transition, but it's going to be a long time and we need a lot of effort there. And that's why we're also trying to do this project to help not only the adults to do this transition, but the students as well, and to learn about. So as I said, we have a few challenges that prevent us this transition. The first one is the lack of awareness about circular chemistry, let's say now circular economy, and the benefit at social and environmental and business level. We also have a lack of specialized training and education, promoting skills necessary to fit the circular economy model. We have a lack of national policies as well, and a lack of also interest in science and technology subjects related to career among students and young people. So the project specifically aims at supporting the initial and continuous professional development of teachers' profiles through the application of practical innovative tools in order to promote circular chemistry in secondary school. And we will explain a bit better what we mean. Again, the needs and gaps here are, we first of all need a practice-based approach to provide resources and tools that are innovative. We've been using technology. I see that you are all using technology also in your classes. And we were trying to transition in that with that approach. We also have a lack of promotion of circular economy principles and also ESD competence within chemistry education, and a necessity of promoting and developing digital learning environment, which is what I was talking about before. So because of that, we decided to develop 4 different outputs. We have the first output, which is based on, it's focused on providing an educational framework for teaching circular chemistry in secondary school. The second output is about the development of a training curriculum, and is directly aimed at secondary school teachers. And we have also a toolkit which we are developing, and that's actually directed to students. So in the toolkit, we aim to develop a game that you can access online, and also a series of informational material of different activities and ideas. The fourth output is actually the development of a learning environment, so an online environment with all these material that we created will be gathered and you can access from everywhere. It's going to be in English, but we're also going to have translation in different European languages. So this is a short overview of where we are at the moment. We have the first intellectual output has been already done. We are now working on the validation phase of the second intellectual output. We also have the toolkit. So now we are going to provide you a series of material that we have developed during this time, including this game, and you will help us with validating and providing feedback to make it better and to make it more enjoyable. So this is what we're doing today. Yeah, and this is the second part of the Gantt. So at the end of August 2023, the project will end. You cannot see here, but we have, this yellow indicates that during that month we will do another event, August 2023, for the validation of the whole project. So that's the, So shortly, I will just introduce what we have already made. We have worked on different good practices on how secondary school teachers teach about circular chemistry in different countries, so the countries that are part of the consortium. We also have interview with stakeholders. We also have some focus groups that helped us create the module framework, which is the basis, the theoretical basis of our project. At the moment, we are validating this part. We will divide you guys in groups where you can look at some of the results that have been produced in this output. We have a training curriculum, a series of slides for teachers, so the teachers will help with that part. And also we would show an educational video, but that is not finalized. Also, the third intellectual output is the one where you guys, the students, will be involved. And that's the educational game that has been developed by Ecologic, and with the help and the collaboration of all partners. You will provide some feedback there and have some ideas and test things there. And then we can have a discussion about it. And the output 4, as I said, is the online environment. So this is where you will be able to access all this material that we created. And now, thank you for your attention. We will have a presentation from the leaders of each intellectual output to show where we are at the moment and what they have done. That's it.
Thank you, Olga.
Thank you.
Hello everyone, pleased to meet you, and thank you for hosting. It was very nice today to meet you in the school and to meet you guys all the testing. So actually I'm not a chemist, I'm not a technician, I have a business economics background. I studied in Rome and then I moved to Milan. So I worked 20 years with chemical companies, and I moved to Milan and I tried to support the chemical industries to obtain funding from European Commission and from public sources to develop innovative ideas within the chemical industry. So I will start from this presentation. I will start from chemical industry in Italy, just to provide that kind of background that has been useful to participate in the project. So this is Federchimica. Federchimica is the Italian Federation of Chemical Industries, and what you can see, all the boxes are 17 associations with sectoral specific. The companies are 1,400 and are divided within this kind of group groupings, methodological groupings. One is for agriculture, fertilizers, others are for plastics, biotech, paints, fibers, cosmetics, detergents. So chemistry is all around us. What when we eat, when we go with the car, there is all chemistry around us. Sviluppo Chimica is a subsidiary, it's a service company which I served for 20 years almost, and we provide the service for the logistics, industrial relations. So there are different functions that are functioning in the company. So this should be used, as you say, energy and sustainable development, something that we are speaking now. So chemical companies are nurtured with
research and development. And research and development provided innovation that serves our life and increase the quality of our lives. Every kind of nation, different nation have different chemical industries. This is specific for the specific industrial structure of the nation and the resources that are available. For example, Italy is a quite diverse country. You have in the south, buildings are made with white concrete because of the sun, but in the northern side is more used to the wood. So you have different chemistries, different related, because are different resources. And so the same is probably for Lithuania and every other European country. So this kind of supply chains just is to represent that not only we have base chemicals producer and the building blocks for the plastics and the material that we use, but then we need a lot of formulators, formulating companies that are serving agriculture, service, or direct consumers. Cosmetics and detergents, for example, are the two sectors that are providing innovation to the final customers. All other chemical industries are providing their product to the other business application. So building, whatever, it's using chemistry, auxiliaries, additives, for every kind of purpose. So already said by Olga, there is ongoing trends that are requiring a lot of innovation. We must maintain our quality of life, reducing our impact to the world. So that's why we produce innovation. We must work on innovation, and we need a lot of quality researchers and chemistry workers. So there are a lot of opportunities within chemistry, not only in R&D and office. You can imagine certification, purchasing, regulatory. There are a lot of space for this kind of knowledge. Federchimica has already a lot of initiatives within education, and this has been tried to be exploited within the project. So we will see something that has been extracted from these activities, and we will, as a Federchimica, we are already waiting out the product of Circle Lab to be used, because this is the reason why the project has been promoted. We need better workers that are not as a teaching instrument. We need the better instruments. So this kind of gamification toolkits, this is something that should enrich and improve the quality of the researchers that are coming out from our schools. And especially in Italy, we need a lot of STEM, scientific, technology, engineering, and management, which are scientific workers. This is something already made. I would just want to say another words about this, about the final aim of the project, which is to efficiently transfer a lot of information for this kind of new chemistry, because it's not the old-fashioned that traditionally teach it. This is a new way to improve the sensibilities of about the resources of our planet. So we must better exploit our resources. The educational models, Olga already said that we were responsible for the first part, which was through interviews and focus group. We tried to select the topics that could be efficiently transferred to the youngers. And so this was the let's say, partition of the argument. We decided to insert a new models after the focus group discussion, because there is a confusion about the concept of sustainability, which differs from the concept of circularity, or is not exactly the same. Not all the things that are sustainable are circular economy aligned, while it's true the opposite. What is circular economy usually is sustainable, because it can improve the relationship between raw materials and the product. So most people can enjoy with the same raw materials that we have, because we can make it circular. And then we have a reduce, reuse, rethink. Someone speaking about 9 R's, so there are even more. So we will see. This is just a way to transfer the concept. Waste as a feedstock. We will speak about that later on, because we will have even the grouping as an exercise. Then chemical recycling and conserve energy. The following slides, we'll just want to extract and present to you something that is going to be refined, because the project is not ended. We are going to refine, we are going to improve the content. We just, with the focus group and some of the knowledge we accrued as an industry, want to provide some of the topics that could help you understand which are the real important things, how to be more efficient in general. So, as a concept of sustainability, there are, you probably already know about that, or you'll listen. There are three dimensions that we must take into account. One is the environmental, one is the social, and one is the economic. Usually, companies think to the economic side. The business is for profit, it's not something philanthropic. But then it's progressively required that companies take care of environmental and social. Not only because there is a government and the rules, the regulatory that requires that, because we know that substance is not good, something is better. But there is even the driver of the markets. The markets require. Fortunately, we are increasing our sensibilities on better products. So there is the social impact. We know that even changing some material with another better will change our structure of our society. Someone will change, should quit their company because there is no requirement for that for their product. So we must take care of all of these dimensions. And then we have the 12 on the right side of the slide, the 12 principles of sustainability, which are quite larger than the ones that we are going to explore with circular economy. So just to be sure that the concept of sustainability or green chemistry, how we want to call it, is something different from circular economy. So then we have the introduction to circularity. This is some slide that has been extracted from the material. Just to, you probably have seen this kind of SDG, the Sustainable Development Goals, which the United Nations launched years ago. And this is something which helps us understand which are all the impacts of our innovation. On the right side, then we see the linear economy, recycling economy, which is famous imagine design of this kind of new concept to see in the economy, this linear against versus circular. The bottom one is quite different. You see a periodic table that is not well shaped, but this is because we want to highlight which are the most available materials and which are in the constraints with respect to our usage. So the little area is because there is little availability. In the green case, probably there is available supply. The red cases, so this is another way to read in terms of business usage of the elements of our periodic table. In this case, another aspect of circularity, I want to I say that chemistry is all around us. Just think of some example that could easily kept in mind. The elements of a smartphone, which are in some cases in very teeny quantities, but very important because provide the kind of performance that are needed to save, to transfer, to connect. And then another message is just to keep the Tokyo Meta was a new way to show sustainability even in the provision of that kind of awards, because that was recycled metals. So reduce, reuse, rethink, and that was another module. In this case, we try to select some of the already well-known established routes of some material which already is giving some headache to the municipalities. We must recover with paper, with aluminium from cans, and so on. In this case, I've just reported regarding the recycling in the bottom. Just as I know, everyone in Europe is recovering glasses separated from cardboard, aluminum, and the lead batteries. Regarding the lead batteries, there should be, of course, some more efforts. So some of the hot topics where we can devote some energy more. On the other side, you see biodegradable, not biodegradable. It's not that simple even, because in some case there are bio-based, which is not biodegradable, or so there will be some section that would improve that kind of knowledge on how to and try to improve the market performance on this kind of these materials. Waste as a feedstock. Just some number to provide the quantity of the products that we have and the tons of waste that is dumped on the planet. Then we see that the car industry is already well ahead and trying to reduce that kind of burden that has on the, for example. So there are plenty of innovation that is ongoing and they should reduce the weight of the car with plastics that can be reobtained by biomass or something like that. Then we see other opportunities. There is discovered, but we have even cellulosic material from napkins that are used that can be reused to obtain some other material for insulation for buildings, other stuff like that. Then we see metal cans, what can we use? This is about chemical recycling. It's a dedicated topic to plastics because actually chemical recycling is another way to see. Nowadays, the standard is still mechanical recycling. We got the bottles that are being used, we collect, and these are mechanically made little and to be reused. But this has not the same quality of the new plastics. So if we want to maintain the performance and the reuse for food contact material, then we must recycle chemically. And then from the polymer, we get back to the monomer to be reused and re-extruded to make new plastics with the same quality, which is something different of what happens today. Conserve energy and reduce emission. This is another very interesting topic and very well aligned with what's going on nowadays, because with the pandemic, with the war, energy is a hot topic, reduce emission is another hot topic. So there is plenty of this information that could help better understand that our actions and the way that we behave and as a consumers, we can even provide that kind of feedback that is needed to improve the system, not only as a researcher, but of course, the knowledge, the brain is the main solution that we have ahead, because we should maintain our quality with the chemical industry, reducing the consumption as much as we can. So possibly becoming a consumer of raw material as a developing countries. We can do that effort because its efficiency and performance is imparted by chemical knowledge. So that's all. I think that has been time.
Yeah, perfect.
Okay, thank you.
Good afternoon. My name is Marika Rapizzola. I have just introduced myself. If someone can help me with the slides. Okay, Olga. I don't want to shut down. Okay, my slides are not as beautiful as Paolo's one, more simple. Okay, I'm representing CSCIs, a consortium of school, municipalities, and the enterprises. We were responsible for developing the second intellectual output, which is a training for trainers. Why we wanted to create this program? Because we wanted to support the teachers in secondary education in transferring contents on green, sustainable, and circular chemistry to their students, and mainly by sharing knowledge on these new topics and providing examples from the industrial sector, but also from other school educational projects on these kinds of topics. And we also wanted to propose new methods, educational methods, to prepare the students for these new challenges. So the program is composed of 7 learning units. You can see the titles there. And the program is organized in 3 main parts. The first part is chemistry in contest. It's an introduction of the contribution of chemistry to sustainability and the contribution of chemistry to circular economy. Paolo has already told a lot about this. And the second part is more technical. We have chosen 3 topics to explore the contribution of chemistry as an enabler of circularity in the field of waste management, the third lecture, managing waste as a resource. And then we have chemical recycling of plastics, and then solar energy, which is the topic developed by our partner, the school educational, the classic education school. Did I pronounce it well? And then in the end, we have a methodological part, because we thought that if we want to teach new topics to our students, we have also to innovate the teaching learning processes as well. So the last 2 topics are on new methods to teach green, sustainable and circular chemistry, but also education for sustainable development. So now I rush into these 7 learning units. The first one was developed by our lead partner, NDU, the Swedish University of Mälardalen, and is on chemistry for sustainability. And this is the table of contents, sorry, back. Okay, so the learning unit starts with the definition of sustainable chemistry in the literature review, and then place this concept in history, the historical perspective on this topic, highlighting commonalities and differences between sustainable and green chemistry. Then the 12 principles of green chemistry are presented, and the links between chemistry and the sustainable development goals are described, and also the challenges of this topic in the future. And then we have the second learning unit, is still in the introductory part of the program, is Circular Chemistry, Science and Industry, Chemistry as Enabler, and was developed by Paolo and his colleagues from Sviluppo Chimica. Indeed, the majority of the content comes from the work they have done on the first intellectual output. And this is the table of content. They explain very well in this learning unit the differences between the linear economic model and the circular economic model, and then describe how circularity is enacted in the chemistry industry, but also in other industrial fields. And they provide many examples of how chemistry can be an enabler of circularity in the textile industry, pharmaceutical industry, the example Paolo have just mentioned. And then in the end, they also provide some background information for the students to better understand and investigate this complex topic. I'm not very good with this. Okay, and now we are in the second part of the process, starting with the managing waste as a resource. This was developed by our Macedonian partner. They're here today with us, the Horde Chopela School, and also Ecology. They created this learning unit together, and it's about waste, managing waste as a resource. And they start with the definition of waste and a classification of waste according to different criteria, like properties of the waste, but also the level of degradability. And then they approach the waste management topic, which is broad, but they have been able to summarize the 12 main principles of waste management. They show the recycling symbols that we can recognize across Europe, even though in Europe there isn't yet a common legislation on waste labels. And then they also present the FIRE model. So what are the actions that we should undertake prior to recycling? Reuse, refuse, reduce, reuse, recover, and then in the end, chemistry is more involved in the 4th chapter, because the author explains how waste can be treated, especially biodegradable waste, through aerobic and anaerobic processes. And they also explain how these processes can become new sources of energies for the future, which are sustainable and environmentally friendly. Did I present your learning unit correctly? Because they are the expert. I'm a psychologist. They are the chemistry teachers, so they can confirm if I'm presenting their content well. And this is a chemical recycling. recycling in the plastic sector. It was developed by our Spanish part, the University of Coruña, SICA, and has a very strong background, scientific background, because it was developed by the researcher of the university, and is an introduction of there is an introduction of mechanical recycling. As Paolo just said, this is the most common way to get rid of recycling plastic, but it has many disadvantages, and this is why we need new ways to recycle plastic. And they explain what are the main methodologies, technology in the chemical recycling of plastic, like purification, depolymerization, and the third one was pyrolysis, right? Okay, I studied. And then to scale up these new methodologies, there are many challenges. It's expensive. Just one challenge is these processes are expensive and the market doesn't have enough appetite for them so far. But the learning unit ends with a very optimistic prospect on the future and innovation in this field. Then we have our Lithuanian partner, the school, which has developed this fifth learning unit on solar energy and innovative solar cells. And today we have a demonstration in the classroom of new type of solar cells. And this learning unit starts with an overview of renewable energies and then focus on solar energy and its huge potential, but also the complexity of its collection and storage, conservation and production. And then the learning unit illustrates different types of solar cells and then focus on a new type of solar cell, sensitized dye solar cell. And the fifth chapter, which was really appreciated by other teachers, because we tested these learning units with other teachers in other countries, they appreciated a lot this chapter, fifth, because it explains how to construct a new solar cell with organic dyes, right? Am I right, Vaida? In the classroom. So every teacher can repeat this process with his or her students. And the last chapter is also very interesting because the circularity of the solar panel sector as well. Is this sector really sustainable? Well, maybe not that much today, but in the future, new technology for recycling solar panels will be developed and increased. And then we have the last two learning units. The seventh learning unit was made by me and my colleagues. Is about new teaching methods for chemistry, for circular, sustainable and green chemistry. We propose many examples from different countries in the world where teachers piloted new methods for teaching sustainable and green chemistry. I don't go into so much detail because we don't have much time, but just to tell you that the last part is also about how to integrate education for sustainable development in the curriculum. And it was developed by the other Lithuanian partner. Where are they? Okay. And the non-formal learning club. Because as the organization name says, they are experts in non-formal learning, and they propose this methodology, non-formal learning, as a very suitable methodology for education for sustainable development, because non-formal learning, as far as I understood, is very participatory, engaging students, local stakeholders, takes place in the communities, is not hierarchical, so for its characteristic is very suitable for teaching, for education for sustainable development project. And they explain the framework of education for sustainable development, present non-formal learning methodology, and in the end they give guidelines for teachers to implement these projects in their specific context. Maybe I rushed through all of this, but thank you for listening to me, and next slide.
Okay, so First of all, I would like to start with my scariest words during my high school time. They were called chemistry class. I don't know about you. I would like to see hands up if there is someone else, maybe between the students who has the same problem, who had the same problem. But because of it, we started from this point, and then we used it to create a game, to create something engaging that is this going to a chemistry class. So we invented the Guardians of the Green Galaxy. Yeah, it's better. So because we started from this place, because our target groups are mainly teenagers, as we see. So we try to do the talk and do the work the teenagers do. So used something they all love and adore. So comic books nowadays, these last 5 or 10 years, are maybe the most inspiring thing for movie makers. So they did whole lot of movies about the Marvel superheroes and all the other superheroes. So we took them as a model, as an inspiration, and put the slogan that we all could be superheroes during this era where circular chemistry can change the world. Because it's all about saving the world. As Paula said, there are a lot of things that can be changed to better and to make our world a better place. So we took this as a mission, as all superheroes have. And we try to give a creative solution to this problem. So this is all about motivation and empowering teams to show that we have the powers through the chemistry knowledge to make this change. And this is how we put it in the first place. So we ask our students to play against the evil pollutants or the evil villains who will and to eliminate them from our surrounding, from our world. And then, okay, this is how we will do it. We have these characters here. We will play it a few moments later, but let's introduce them. This is the main guy. He's Captain Earth. So he has this superpower to remanufacture things. So he stands upon his hill, oversees everything in the world, and he sees where the problems are and remanufactures the issues. The next superhero is Wonder Water. She has this power of cleansing because through her powers we recover chemical substance. These are the gang of four people. So incredible. Circular 4. They are doing the recycling. Every one of them is carrying a recycling bag and puts things inside and throws a new product afterwards. Then this is the guy, Incredible Junk. He's just jumping into situation where we see tons of garbage, and he remodels the place into something beautiful. This girl is Air Woman. She's flying all around the place, carrying a boomerang, and whenever she sees some toxic substance, she returns it up to the space. The next one is the Dr. Change. She is master of disguise, so she can go through shapes and forms, and that is how she refurbishes things she finds in the surrounding. Then we have this Green Gordon guy. He's the fastest guy around. What he does is he's moving with his sword and he rejects all the unwanted compounds found on Earth. About the details of the game, we wanted to, because we use superheroes and they live mostly in comic world situations, so we wanted to keep this as a design. These are things that we will pass during the workshop, and these are the cards, the heroes that we will use, but also There are these villains, these bad guys who will try to ruin our world. So here is the Captain PFAs. We will try to eliminate him from the world because he's everywhere. She is the one that goes into the textile industry. She is trying to do bad stuff with our clothes, trying to use some harmful dyes. The Marketo guy is the one that keeps producing garbage and plastic waste. And the last one is toxic. She is putting toxic fire retardants into our products, into our electronic devices, into our cars, into our planes. We will try to fight them off. And also the heroes will have civilians to help them. So we put roles for civilians too. So here we have high schoolers, teachers, parents, politicians, business owners, and each and every one of you will be given a role which you will have to defend based upon the situation. And the situations are, we will try to go through them quickly now, but we will do them more detailedly later. So this is the situation in the textile industry. We try to fight against Captain PFAs. And we have these weapons to choose from. In the next situation, Underwater is going to a dinner. We have this common situation, and there these two guys, Captain PFAs and Marketo, are trying to mess her dinner. There, with the help of the civilians and the heroes, we will try to save her dinner. This story is with Green Gordon, and we'll try to help him remove things, harmful things from the market shelves. This is the Incredible Junk story. We'll try to recognize all the things and make them into something better. This is another example of the textile industry. The Circular 4 will fight here against Coloria. And the last story will be for Aero Woman. She will be fighting against the toxic, against the materials used in the aerospace and automotive industry. And for now, this will be all. We'll try to play the game later on. Thank you.